Yes, sir, you are audible, sir.
Okay, good.
It is
So
fine.
let me start today's session. I welcome you all again for the second session, and this will be focused on Python programming mostly. And yeah, so Karthik here again. So let me start without wasting much time, right? So I'll cover a quick recap of session one, and then I'll again talk about the pipeline. Yesterday, I was mentioning about the basic building blocks that any image processing or computer vision task that should have. So I'll again briefly talk about that particular pipeline. I'll also speak about Python for optical character recognition, right? So I'll pick up this application of OCR, and then Python, how Python is being useful for it, how Python can be used to
Hello.
solve this OCR problem. Also, I'll see if time permits, I'll touch upon this pathway to TCS Research and Innovation Labs. Else, I'll cover that tomorrow. Right. So let me get started, bro. As I said yesterday, vision plays a very important role in scene perception. Right. So when compared to the other sensors like touch, taste, hearing, and smell, vision takes place. For 83% of your perception of a scene actually depends on your vision sensors. That's how important the vision sensors are. That's exactly the same reason why, if for all the industrial automation tasks, the vision sensors are extremely used. Okay, and one yet another advantage with the images and the videos is majority of the times you can perform a similar operations across all the pixel positions, and that itself will be an added advantage because you can effectively perform all your image processing and the computer vision tasks on image processing and computer vision task on the GPUs which are available these days, right? So every industry has a requirement for image processing and computer vision because in order to do the industrial automation, they need vision sensors very much. And of course, domain knowledge plays a crucial role while designing the algorithms for a certain application, right? So it's very important in that sense. It's also the cost of data acquisition is huge for certain applications. Suppose, say, yesterday I've taken the deep sea explorations. Let me take the satellite imagery today. If you see, the satellite is capturing the data, and once it has captured, suppose, say, because of the haze or because of the cloudy conditions, your the data acquisition didn't happen properly. Okay, so you cannot capture it again because the satellite is moving continuously and coming back to the same position again. It will take certain time, and of course the conditions might change. I'm sorry, guys. So the cost of data acquisition is huge for certain applications, right? So that's satellite can come again and capture the data, right? So that's another example where image processing and computer vision engineer role plays a very will be very crucial as such, right? So and then yesterday I was talking, right? So let's say if I have to talk about more applications, these are some of the applications that TCS has been working on. Forest inventory counting to count the number of trees in the forest, especially useful for paper manufacturing firms. They have to do some kind of a tree number, counting the number of trees, as well as counting the each tree, the species, the number of trees belonging to each species, right? So that's also very important. That's the reason the forest inventory counting plays a very crucial role. And warehouse monitoring, right? So earlier what they used to do is, you must have seen these Amazon and Flipkart warehouses, right? There'll be huge warehouses, and then they used to be the lot of carton boxes will be lying around, and then one of the earlier what they used to do is, the people who used to work there, the staff who used to work there, they used to go to every carton box. They used to use this laser scanner and then read the barcode. The way you are reading the QR codes when you are doing a Paytm transaction or a PhonePe transaction, right? In the similar way, earlier what they used to do is they used to read the barcodes, and then that's how they used to do the inventory stock maintenance. Okay, suppose, say, if this the height of the warehouse is also huge, and if a particular carton box is not reachable to a particular person, then what happens there is, they used to use the crane. They used to either the person used to go to that place and then get the scanning done, or they used to get this carton box down and they get the scanning done, and that's how they used to do this warehouse monitoring as such, right? So that's a laborious process. Now, what TCS has offered a solution is they started building the drones now, right? They have installed the camera on the drones, they have carried the drones, and then they were flying. Now, what are the different challenges that can exist in this scenario? Okay, let's try to analyze a bit more here, right? So, when can you do your Paytm transaction well? When your camera is very close to your QR code. When it's very, very far away, it will not be able to do its job. Okay, but camera on the drone and that drone going closer to the carton box will be very, very dangerous, because the drone can hit the carton box. Okay, and now from a far away distance, how you can effectively read the barcode will be a biggest challenge. On top of which, the drone is continuously moving now. Okay, when the drone is in movement, what happens? The images and the videos that you capture will have certain kind of motion blur in it. Okay, now, having all these challenges, in spite of all these challenges, how image processing and computer vision engineer will play a useful role here is whatever images the drone must have captured. Okay, and it should the image processing and computer vision engineer should be able to restore the blurred barcodes, right, and then infer the information out of it. So that is a role of an image processing engineer, right? So now, another application, high voltage transmission lines inspection. Now, earlier days, they used to take the helicopters and go around the transmission lines, and they used to inspect whether everything is perfectly fine or not, which is a very, very dangerous job, right? So it's a high voltage lines. If a small mistake happens, both the person as well as the helicopter is gone, right? So it's a huge loss again, right? So so now what people have done is they have started building drones on which they have installed the cameras, and then now that camera itself will be used to capture the pictures, and then now the person who is operating the drone from the bottom, he will be monitoring whether certain kind of an attention is needed for a particular transmission line or not. Okay. In the same way, windmill inspection and the document digitization happen. We will dig more into document digitization, but before that, let's try to get back to some of the basics, right? So how human visual system process, right? The light comes into your human eye falls onto the retina, right? What is retina comprises of? This retina has major
Karthik sir. Karthik sir.
For detecting the color information. Yes, please.
Sir, your last voice is garbled. Can you repeat again?
Sorry?
Last 10 seconds.
Okay. Am I audible now?
Yes, sir. Now audible, sir.
Okay. So how do human visual system process? The light comes into your eyes, and then it falls onto your retina, and your retina has this two different kinds of cells called cone cell as well as rod cell. Okay, rod cell is all about capturing the intensity information, whereas the cone cell, if you see the colors, the three different cones are there, and then the red, green, and blue, right? So red, green, and blue is like each of these cones actually will be detecting the individual wavelengths as such, right? So now let's go back to some more fundamentals. See, this is how the human visual system works, but how your camera system works is like this. Now the illumination source is there, it falls onto your scene element, and this reflected light comes back to the scene element. The reflected light from the scene element will be coming back to the imaging system, and then now whatever light intensity which is falling onto this sensor array, okay, that will be digitized, and you will store the image as a JPEG or PNG or whatever it is. Okay, and then this is how images are found in your basic camera system, right? So when I say there are two kinds of images: the grayscale images and the color images. Okay, the grayscale images, in loose terms, actually many people call it as in black and white. images, right? So which is not correct actually. The right word should be the grayscale. When if I say as a black and white, then I have only two intensities, either 0 or 255 or 0 or 1, in whichever scale you represent your images with. Okay, so how the basic images are represented? Okay, the basic images are each number in that matrix actually will represent a pixel or an intensity value. Okay, so this is how the images are represented in a software program. Okay, now collectively all these intensities together in a certain pattern will produce this kind of an image. Okay, when I'm saying that this pixel has 112 number, that means this number actually is directly proportional to the number of photons that reach each and every sensor. What's happening here? The light is falling onto the scene element, and the photons are reflected back onto the imaging system. And suppose say this particular intensity is 112, that means that number is decided and now here if it's a color image, how do you define a color image? This color image is defined as three different channels: red, green and blue. Where is this red, green and blue is actually coming from? Is coming from the human visual system, because now whatever, whether it might be camera or any other kind of system which you would be developing, actually you try to get motivated from the biological counterpart. Okay, are formed in the human visual system. Okay, then only I'll get to know, okay, now I know how images are formed in human visual system, and what can I do to build such kind of a system which can replicate the way human visual system works. Okay, of course we are very far away from replicating the human visual system, but that's how you will start building your problem on whenever somebody is designing a hardware. Okay, and now the color image is represented by three channels: red, green and blue. Okay, again it's a matrix of values. Here it's a matrix of values either as a single 2D array, or as a, if the same set of intensities are there in all the three channels, still it appears as a grayscale. Okay, and different combinations, again if all the three channels are different set of information, then you call it as a red, green and blue, and the combination of these three colors actually will produce the several other colors which are there in the visual wavelength range, right? And let me go back.
Karthik sir. Karthik sir. I request participants to stay tuned. There is a technical glitch at the resource person end. I request participants to kindly cooperate with us. I request participants to please stay tuned to the session. I request participants to stay tuned to the session. There is a technical glitch at the end of the resource person. Meanwhile, I will share the day 2 attendance link. I request participants to please fill that attendance. Karthik sir?
Am I audible, Naidu
Yes sir,
garu?
you are audible sir. Please go ahead.
Okay, yeah. I'm sorry, guys. There was a power cut, and then there was a sudden drop in the signal. Okay, now if you see here, there's a color image, and this is how the color image is represented now, right? It is represented in the form of three different matrices, and each of these three matrices indicates the different channels, right? So the first matrix being the red color, the second matrix is the green color, and the third matrix is the blue color. This is how it's generally represented. Where is this red, green, and blue is coming from? It's coming from this rod, the cones which are present there, the human visual system, right? If you are this is how you replicate the human visual system, right? Of course, we are very far away, as said, but this is how you replicate it. Okay, let's go back. Let's do a little bit of programming and then come back again. Okay, so this is a Colab environment, and then this is a Google's Colab. And one of the biggest advantage with Google Colab is you have access to free GPUs, and then you can work really well by using this Colab. Of course, there will be few interruptions. However, since it's a free GPU, almost 11 GB sometimes or 16 GB GPUs will be given, and so that's the biggest advantage over here. Okay, so now let's get connected, and this is you call it as a cell, and then when you press this particular code will be executed. Okay, and where you will be storing all your data, and you will have your Google Drive present over here, right? So once you have your Google Drive, and then your Google Drive will be mounted onto this session, and then that's how you'll be able to store your data. Okay, if you see here,
I request Ganga. I request Ganga Jakkamsetti to stop his screen presentation. I request Ganga Ramesh Jakkamsetti to stop his presentation. I request M. Prem Kumar to stop his presentation. I request M. Prem Kumar to stop his screen presentation. I request participants to stay tuned to the session. Karthik sir, are you there?
Yes, sir. Am I audible?
Yes, sir. Now you are audible, sir.
Yeah. What was the last slide that you have seen?
It's useful Python packages
Okay, okay. Thank you.
for image processing.
Okay, okay, sure.
Sure.
Okay, this is the useful Python packages for image processing, and TensorFlow specifically is from Google. I believe this is one of the very useful Python package for doing especially deep learning based algorithms, right? So and of course there are several other libraries, and we'll make use of them today in our experimentation. Let me stop and restart this. Okay, there is some error. Okay, it will ask me to connect to Google Drive, and I'm trying to mount because I have to store my data, right? So the data reading and the data writing will happen from Google Drive. I have to sign in through Google Drive now. Okay, so in the meantime it gets mounted. What I'm trying to do is here is so there's a folder called what do you say, the Select Smart demo here, and then that particular folder I'm entering into. If you have used command prompt either in Windows or Linux, the CD is the command that is used for it. Okay, and afterwards this is one such library, right? OpenCV libraries. And then matplotlib, right? So these are the two useful packages which I've shown. Why I'm using both? Because to display an image, I cannot use OpenCV libraries inside a Colab environment. There is an incompatibility issue, so that's the reason for displaying alone I'm using matplotlib. But for OpenCV is very rich in some of the image processing algorithms. It has very rich image processing algorithms. That's the reason for the rest of the functionalities I'm using OpenCV over here. Okay, the cv2.im read, which actually reads this cameraman.jpg image from your Google Drive, and then this parameter 0 ensure that it is read in grayscale. Okay, I wanted to demonstrate you the grayscale images, right? So I'm reading that in this img variable. Now what I'm doing is I'm printing this img variable. What did I say? The images are nothing but it is represented in the form of an 2D matrices or the 3D matrices. Here, if you see, since it's a grayscale image, actually it's represented in an 2D matrices. However, grayscale images can also be represented in the 3D matrices as well. Okay. Now, what I'm trying to do here, plt.im show, if I'm using it, it will show the image in the grayscale over here. It will display the image over here. Okay. What is PLT? It's an alternative for pyplot function, which is there in matplotlib, right? So pyplot will help me to plot the images in my environment. Okay. In the same way, if I'm reading a color image, how will I read it? Okay, IMG. Again, there is no difference in the way I'm reading my image. Okay, but if I'm using matplotlib, if I'm reading through OpenCV library, and if I'm displaying it through matplotlib library, then there is an incompatibility issue over here. Okay, because I'll just show you. So the actual mandrill image is like this. Okay, but when I'm displaying it through matplotlib, there is a color distortion over here. Okay, why it is happening? Because OpenCV actually reads an image in again three-dimensional matrices, okay, but the first channel will be corresponding to blue, second channel will be corresponding to green, the third channel will be corresponding to red. Okay, that's exactly the same reason why it's almost like an inversion that is happening over here. Okay, and so if I don't understand this, how OpenCV is reading and how Matplotlib is displaying, I will think that this itself is the correct image. Okay, but this is not the correct image. So what we are trying to do here is there is in order to have some kind of an coherency between Matplotlib and OpenCV libraries, what I'm trying to do is I'm reading this image in OpenCV and I'm using this some kind of an color transformation here. Okay, I'm converting this BGR array into RGB array. Okay, and now if I display this image, it will display properly. And if you see here, I'm printing the shape. I'm using the shape attribute of IMG. Okay, and then I'm displaying its value. Okay, if you see here, this is a 3-channel. It has 288 rows and 288 columns and 3 channels. And each of these 3 channels, the first channel corresponding to red, the second channel corresponds to green, and third channel corresponds to blue. Okay, this is about color images, right? So reading color images and the writing color images. Okay, if you see here, now the Google Drive, it's asking me amount. Okay, and then it is asking me to use that link to go somewhere to generate the authentication code. I'm choosing the account on which my Google Drive data is available. Okay. I'm allowing this. I'm allowing my Colab environment to access the Google Drive, because Colab is a different application. Google Drive is a different application. There should be some kind of a permissions that should be given to Colab to access your Google Drive. Okay, I'm just copying that code and then I'm entering this authorization code here. I'm pressing enter. Okay, now if you see, mounted at content/drive, and I'm refreshing this. Okay, if you see here, I have my drive over here. The Google Drive data is mounted over here now. Okay, I'm entering this. If you see here, there are several images which I've stored and which are there, and then now all these images which I'm trying to process over here will be accessed from my Google Drive. Okay, let me try this. The earlier day I was not able to execute, but okay, this is to see NVIDIA drivers. Somehow there is some issue, but let me, that doesn't matter here for our discussion today. Okay, let me go back now, right? So to the PowerPoint presentation, we have used Matplotlib, we have used OpenCV. Okay, we'll slowly use NumPy and other libraries also. And so the basic block diagram, right? So the data capture, pre-processing, feature extraction, region of interest, scene inference will map this OCR application that we are going to deal to each of these boxes today. Okay, and the OCR application is about transforming the 2D image of text that could contain the machine printed or handwritten text from its image representation into machine readable text. Okay, what does it mean? Okay,
Karthik sir.
Yes.
Sir, sorry for the disturbance. Please share your screen once again. Some participants has disturbed the screen share.
Oh, okay.
I request participants to stop their screen share.
Is the screen visible, Naidu garu? Is my screen visible?
Yes, sir.
Okay, good. Thank you. So how my images are represented? This is how, as a matrix of values, this is how it is represented. Suppose say there is some text in my image over here. Okay, and then those are also represented as a matrix of values only. Okay, from this matrix of values, if it is here, if it is written as good morning, okay, then how my system should be, you should have some technology to convert this matrix of values into interpretable text. Okay, that is all about the open character recognition algorithm is all about. Okay, so for automated text entry into computerized systems, OCR is very, very helpful. Several challenges exist in digitizing the documents, right? So let's look at these challenges one by one, right? So before going them, also let's talk about some of the applications of OCR today. Okay, and building license plate readers. So suppose say these days somebody violates traffic rules in cities, especially. Every police person, the traffic police has the point and shoot camera, and then he captures a pic of the license plate, and then he sends it across to maybe to concerned place where the license plate information is inferred, right? So see, a traffic police might capture some few hundreds of images, right? So a person cannot go through it will be a very tedious job if a policeman is going through all those images and identifying the license plate numbers in those images, right? So now, can we use OCR in such cases? Because the license plate numbers, they are alphabets and numbers only. It's alphabets and numericals only. Okay, they are in some form of characters only, right? And now, how do you from those images, OCR can be used in order to recognize the license plate numbers also. You can build an automated application which takes images as an input and gives you the license plate number as an output. Okay. And digitizing invoices. Okay, suppose say a person is being there, a businessman is there from long time, maybe 10-20 years he's been running his business. Okay, however, there are lots and lots of bill books in his home. Okay, and then which are getting piled up year after year. Now he wants to get rid of all those bill books, but nevertheless he wants to digitize those invoices. That means he can capture the images of it and then digitize and then store it. Okay, he can store it in the form of a digital form, maybe in a couple of hard disks he can store, and then he can safely do it in a very lesser space. Okay, that's one of the best part of OCR. You can reduce your physical space which is there. And digitizing the menu. Suppose say you have a restaurant, and then every time you introduce a new object, you are modifying your menu now. Right. So now, if I'm able to digitize them, I can store all my old menu cards. Right. So it's not only about a restaurant, but there can be several other example case scenarios also. Something like digitizing ID cards. Okay, I have a company ID card. I want to digitize it now. I want to capture an image and then infer some kind of an information from it. Right. So this is all about these are the several different applications of OCR. Okay, and while performing OCR, optical character recognition, these are the several different challenges that you will have. Something like black ends. Okay, when I mean by black ends, these are the black ends. Okay, these are the black spots which are there, which will not allow you to read this text information correctly. Okay, in the same way, you have some cases when you are reading through some low quality scanner, what happens is your documents will be of poor resolution. Now, if you want to infer the text which is there, if you want to digitize this kind of a text, then you have to improve its resolution first, and then you'll be able to do it. Okay, then only you'll be able to read the text properly. And I have a perspective distortion inside my text. I have an what do you say? Some form of a transformation has happened, or in the way my images are captured, and I have to first correct for this perspective distortion. Then only I'll be able to perform optical character recognition on top of this. Okay, and I have a rotated text. I have tables like this, but somehow my image is rotated. Now, however, the optical character recognition generally assumes that the characters are read from top to bottom. Okay, if I have a rotated text, then it will give me some kind of an erroneous results. Okay, I have some kind of an skewed text. Okay, yesterday I gave you some reading the cables which are there inside the water. Okay, if my water surface is dynamic, because of which you have some kind of skewed text, and the text which you see in these images and the videos will be highly distorted, right? So I have watermarks also, right? So I have a light few watermarks. Because of these watermarks, the text interpretation will be continuously will be disturbed as such, right? So these are some of the challenges, and these are the steps in OCR. If you see the pre-processing, after the data is being captured, the pre-processing, text localization, okay, where all text is there in the specific image, okay, not this complete image doesn't have a text, okay, there are some white regions, okay, not the complete image is filled with text, okay, you have to identify first where the text is there. Then the character segmentation and character recognition, you have to segment each of these characters and then recognize those characters. Suppose it is D, it should be able to tell this is D, this is E, this is S, okay, and then you are able to do that job, and then you are able to infer it, right? And now post-processing. Now if you want to do some kind of a post-processing, suppose say you are documenting this kind of tables, and then you are building an OCR system also at a bigger level. You are asking in how many documents Ram Kumar name is there, okay, or what is the phone number of Mr. Ram Kumar, okay. Then if you ask this question, then my system should be able to find where in the image where the Ram Kumar name is there, as well as his phone number. It has to extract that particular phone number, right? So that kind of an intelligence, if it has to do, then you have to do some kind of a post processing, okay. And one of the useful software for text recognition is pyTesseract, okay. And then initially it's released by HP Labs, later it's developed by Google, okay. Based on the neural networks, it is being built for recognizing the text, and install the packages in the Tesseract OCR and the pyTesseract on Colab, okay. So if I have to use them, then I have to install these two packages, okay. Let's go back again, okay, and then I'll show you how the installation can be done of these two packages. Majority of the packages are automatically installed by Colab environment. However, this is the way you install, okay. And yeah, you install these two packages. Once you install these two packages, it will say some successful installation is done, and then now you are reading the text image. Now once you have installed them, you are importing pyTesseract library, okay. And then there are few other things we will be using and then in our code, and then that's the reason this import has been done, okay. And now what is the first thing that I'm trying to do? I'm reading the image, okay, by using imRead function, okay. I'm passing it on to some function called boxplot. What this boxplot the way I have done is, the boxplot, once you passed on the image, okay, and then what I'm trying to do here, okay, the Python language operates on pass by reference, right? So there are two things, pass by value and pass by reference. When I'm passing, if my functions are obeying pass by value approach, then I have some kind of a value that I send into this function, even if the value is the value is manipulated over here, the variable is manipulated over here, but still there won't be any effect for this variable which is there outside that function, okay. In the same way, if it is a pass by reference, that means any manipulation that you do inside the function over here, it will be reflected back here also, okay. So now the Python operates on pass by reference kind of an approach. So what I'm trying to do is, once I pass this image, I'm trying to create a copy of it first, okay. So img_copy is a different variable as such, okay. Now once I created this copy, I pass this imcopy here to this particular function called image to data, and then extracting something called dictionary, okay. Dictionary is a kind of data structure in Python, okay. And then now inside this dictionary, you will have something like key value pairs. And now here, if you see for this text, that means one of the keys for the dictionary is text. That means it's trying to store all the information related to text which is there in these images into this dictionary D, okay. And now the bounding box where those locations are there, that information is also there inside this dictionary D, okay. Now I'm using this cv2.rectangle, okay. having this, passing this im underscore copy into the cv2.rectangle. I'm plotting this around this function, right? So where x represents the x coordinate, y represents the y coordinate, and w represents the width and the height of the bounding box, and because of which I'll get this kind of an image, right? So the output of box plot looks like this. It will draw a bounding box around each word. Okay, there is an error. However, there is some error here, but however, this to maximum possible extent, this has done a great job. The pyTesseract library has done a great job. Now, what I'm trying to do is, I want to see whether pyTesseract library will be able to detect the same text. Okay, here if you see, I have used this function called pyTesseract.image to string. That means whatever text content is there in this image, it will be converted as a string, and I am displaying that string value. And what is it written? Whatever it's written in this image, this is how it is displayed as a text. And now what I'm trying to do is, if my images input, the images that I give as an input to pyTesseract library has some form of a distortions or a degradations, okay, then what happens? Okay, then what I'm trying to do here is I'm adding noise onto my on my input images. Okay, so I'll use the same text image. I'm reading it by using a grayscale format. I'm passing on to this function. This function adds something called salt and pepper noise. And then salt and pepper noise is all about, suppose say you have a white color plate, and then you randomly sprinkle around salt as well as pepper in the mixed fashion. It will like white and blackish kind of an spots that you will have all across the image. In the same way, this noise which I am trying to induce in this image, it's a salt and pepper noise, which will imitate what I have said just now, sprinkling that salt and pepper across an across a what do you say, some plain background, right? So now if I'm displaying this image, plt.im show, I'll display this noisy image. Okay, now I'm trying to draw the bounding box around the noisy image. Now I'm trying to see whether pyTesseract library will be doing a great job or not. If I'm passing this, I'm getting this noisy text box plot image. Okay, I'm also displaying it. If you see, it's highly erroneous now. Okay, here the structure of the bounding boxes is very neat. However, when I'm adding noise, the pyTesseract library will go out of toss. Okay, so that's the reason. What is the first block that I've told you here? In the after the data capture is done, the pre-processing. Okay, this is where first you need to find out ways in order to remove the noise in those particular text and send it across to pyTesseract, which will do this feature extraction and the region of interest identification as well as scene inference. All these three blocks, the functionality will be done in the pyTesseract library. Okay, now for removing the salt and pepper noise, what I've done is I've used the simple median blur. Okay, this median blur, I'm passing this to the median blur, and then the parameter is the window size here. Okay, here which I'm giving as an input, and then noisy image, I'm reading it. Okay, I've stored the noisy image in my Google Drive. I'm reading it and then removing the noise and then displaying the noisy image, and then as well as I'm drawing a bounding boxes around the text which is there in my noisy image, right? So the denoised image. So now I've denoised the image here. Okay, by this remove noise function, I've denoised the image. If you see here, if I give back to this denoised image back to the pyTesseract, it will be clearly detecting the text. Okay, that means if you have some sort of distortions, that first, then you have to correct for it. Then only your pyTesseract library will be able to work properly. Okay, watermarks, as I've said, is another form of distortions. Okay, I'm displaying the reading and then extracting the image data into this variable extracted data with watermark. Okay, then I'm printing it. If you see here, there is no proper structure in it. Okay, there is no proper structure in it. However, this is the image that I'm trying to read here. This is a tabular information and there's a watermark on it. Okay, now if I write a small function in order to remove the watermark, okay, I'm not explaining this logic. However, I'm going to share this Python notebook with the organizers, and then they will mail you so that you can experiment it by yourself. Okay, and so I've written a small logic here. What is my logic here is, see, if you see here, there are only three colors, either black, white, or the color of this watermark, this grayish color of this watermark. If I am identifying this grayish color of the watermark, what is its intensity values? Okay, all that I have to do is I have to replace the intensity values of in these regions with the background information. Okay, once I have done that, I'll be able to recover this image without the watermark. Okay, and if I give this restored image to my pyTesseract library, then it will be reading this textual information very nice and the structured way. If you see this, the tabular structure is very well maintained. Of course, there are some errors. However, there is a lot of scope to improve further. Okay, now let me show you. Now there's an what do you say? There's a what do you? I want you all to think about this challenge, about this image that I'm going to show you now. I have given you the logic for this watermark, right? So let me open this image. Okay, this is a watermark, right? So I've removed this watermark now. Okay, I have this watermark, and then I have to remove this watermark now. Okay, now if I have the watermark in the form of a color, okay, I want participants to think over on this and then write a small code if possible in order to remove this yellow color watermark. Okay, so what you need to do is you need to think if the watermark is in the color form. Okay, I will send this test images also. Okay, and then what you need to do is if you are able to write the code, that's perfectly fine, or else at least you should be able to tell me what is the logic that you want to use in order to remove this yellow color. Okay, yellow color watermark text. In the same way, I have different colors like this. Okay, have the grayish color is little intense over here, right? Have a different language here. I'm not sure if it's a Urdu or Arabic or which language it is. Okay, and then there's a green text as well as a greenish color watermark. Okay, for all these cases, can you think of some way in order to? Can you think of some logic on how you can remove this watermark? This is what I want the audience to think over today, and then when I come back tomorrow, maybe if you can tell me suggestions, that'll be really good. And then let me go back to the PPT again. Okay, now we have taken a look at the pre-processing and the rest of the blocks also. Okay, the feature extraction and the region of interest. How we are even doing the scene inference, we are asking, we have written a code in order to determine what text is there also. Okay, in the same way, any kind of image processing or computer vision problem you can map into one of these things. Okay, and this is my email ID, and this is how I'm there on LinkedIn. And this slide I'll cover it tomorrow at the end. Okay, that will make a lot of sense tomorrow. Okay, and that's all from my side. Thanks for your patience listening. And if you have any questions, you can come forward and ask. You can even type it on chat box. I can look into it.
Karthik sir.
Yeah, good evening, Karthik sir.
Yes, sir.
Karthik sir.
Yes, sir. Yes, please tell.
There is a comment raised by Pratibha Varghese madam that she is asking us to explain Colab Python codes if possible.
Colab Python codes if possible. Okay. Which Python code she want?
Pratibha Varghese. Pratibha Varghese madam, kindly respond. Madam, are you there?
Yeah, sir.
Please respond to sir.
So watermarking codes, watermarking program codes.
Watermarking program code. Okay, let me go back. Okay, so what I have to do here is I have to identify where the regions of watermark is, and then I have to replace that watermark regions with the background text. Okay, so that is what I have to do. So see, if you see here, there are three colors. Either I have white, black, and then grayish color over here. So what I'm trying to do here is I am using a target variable, okay, which is filled with all 255s in it. Okay, so I'm reading this image input, this complete image input, and then I'm generating with that shape. The shape, I'm extracting the image size of this complete image size, and then with that as a shape variable, I'm generating those many number of ones in the same matrix. Okay, and now I'm extracting in all the regions in IMG where all I have less than 60 intensity value. Okay, as I've said, right, every pixel has some kind of an intensity. So I'm trying to identify where all in my image regions I have less than 60. So I've experimented with 30, 40, then found that for this image 60 turns to be an what do you say, optimal number to remove the watermark. Okay. Now all those regions, what I'm trying to do is, now I have all the indices where my image pixel values are less than 60. That means this individual watermark areas as well as this blackish regions. Okay, so all those regions where I have less than 60, I'm trying to copy into this target variable. Okay, and that itself, if I'm representing, that itself will give me remove the watermark in my image. Okay. So the whole idea is you have to identify the pixel regions where this watermark is, and you have to replace all those indices with values with the background values. Suppose, say, in this region, if you see here, the background value is white. Okay, and then I have to replace this pixel intensity with white. However, if you see, the table border is coming over here, and then it is overlapped with the watermark. These regions I have to replace it with black. Okay, so that is what I need to do. So here is a hard-coded threshold I have used. However, the ideal way to do is you have to automatically identify what is this intensity value and then replace it with the background value.
Okay. Okay, sir.
Okay. Did you get the logic, madam?
Yeah, sir.
Okay.
Sir. Okay, sir. Sir will be sharing this IPython notebook today.
Yes, I'll send it across, and then I'll ask them to share it across to you.
With the images also, with the same images also we need.
Yes. Yes.
Okay, sir. Thank you, sir.
You're welcome.
Mr. Samir? Mr. Samir? Mr. Samir?
Hello, yes, sir.
Please proceed.
Sure, sir. Good evening, Karthik, sir.
Yes, Samir, please go ahead.
Yes, sir. You said first in first slide you in image that we have captured the number plates from the moving vehicle. Is a video analysis, right?
Yes.
Is there special libraries available in Python to targeting that particular particular number plates? Otherwise,
Samir,
we have to generate.
Samir, actually, you can use the same OCR technology for reading the contents on number plate.
Okay. Same technology for that?
Yes, you can use the same technology. However, some kind of pre-processing should be there, because the traffic police will capture those license plates from very randomly, right? He will not have some kind of an orientation. The camera will not be oriented properly there in that case. Okay, so the traffic police should first orient that.
Yes. We have to capture such a huge number plates. We need to buy special cameras, right? We have the digital high quality cameras.
Not required. Even your cell phone cameras will work.
Okay. Okay.
Okay.
After that, yes, sir. Sure, sir. Thank you.
Yeah. Welcome.
Karthik sir,
Yes, sir.
there is a comment from Sandhya Teku.
Okay.
Are the Tesseract and pyTesseract packages be downloaded for digitizing document applications? Are they necessary for processing images?
No, there are several other packages also. I have used this because they are little easy to use and they are robust. Okay. And then within the Colab environment, if they want to install, these are the two commands they can use. Okay. If they use just these two commands, these packages will be installed.
Sir?
Yes. Am I audible?
Yes, sir, you are audible, sir.
Okay.
One participant requested your comments on computer vision using LabVIEW, how it is compared to other platforms.
Okay. Frankly speaking, I have never used LabVIEW because LabVIEW is a paid software, right? And I'm not sure how efficient it is. And even my company also doesn't use LabVIEW. And majority of the industries, they recommend to use these open source tools like Colab environment or PyCharm. These kind of an IDs, Anaconda, right? These kind of an IDs they will encourage to use. But LabVIEW is a paid software, but so I have never used it as such. I was not sure if computer vision can be done in LabVIEW or not. But the paid softwares like MATLAB and LabVIEW are not encouraged in industries because they always look for open source solutions, right? So because open source solutions are like free, they are available for free. When something is available for free, why do I have to pay money and then get it, right? So that's the logic that they use, and then they never look for LabVIEW kind of a setup.
Yeah, Karthik sir.
Yes, Samir.
Is it Colab is open source or
It's an open source.
anything?
It's an open source, Samir. It's an open source. You can just use that freely.
Okay, it's just like Visual Studio like that. Visual Studio Code like that.
No, Visual Studio, yeah. To a certain extent, you can use it. The professional version you have to pay, but for students and faculty who are doing research in deep learning, Colab is good enough. As yesterday, one of the madam was mentioning that she was using Kaggle. In the same way, Colab is also good enough.
Okay, sure, sir.
Karthik sir,
Yes, sir.
one more question from Anita Perla. Sir, in Python, any toolboxes for image and video processing like MATLAB, and how Python is better than MATLAB, which is more appropriate?
Yeah, I would recommend Python only, madam, because for performing images and videos are too huge. The data is very, very huge. Okay, so right, so I don't know. The MATLAB will be too much for images and videos, and it will be very, very slow also. If you are able to learn Python and implement, that will be really, really good.
Yeah, Karthik sir.
Yes, sir.
Is it OpenCV? We can use OpenCV, but CPU performances are very high. But how can we overcome that CPU usage and RAMs?
I didn't get your
OpenCV
question.
Sir, OpenCV has a huge CPU usage, sir, by using OpenCV.
Okay.
Is there another tools are available for same like that OpenCV?
No, to certain extent you can use. See, they are OpenCV code is very optimal, and then I think this is very. So there are few other libraries also. However, OpenCV is the best as far as I know when image processing is concerned.
Okay, sure, sir. Thank you.
Hello. Hello,
Yes,
sir.
yes, madam.
Sir, can we convert the MATLAB codes to Python codes?
I think there are few softwares. Yes, you can do that.
So can you please tell me that software?
I'm not aware of it. Generally, what I do is, madam, I look at the MATLAB code and write the Python code by myself.
Okay, sir. Okay.
Okay, I have never used the converters as such. The converters are not very optimum. You will have lots and lots of errors in it. After you try to compile the Python code, which is converted from MATLAB, you will have lots and lots of errors. So it's not optimal to use also.
Okay, sir. Okay.
Okay. But learning Python doesn't take too much time, madam. It's very simple. I think at this juncture, let me share you my experience with Python. So earlier, I used to think that learning a new programming language is like a big task, right? But however, it's not. It's not that. It's not like that. Okay. It's almost like if I know fundamentals of one language, I can really map it really well. Okay. So it's the same thing I applied when I learned Tamil after I did my PhD in IIT Madras. My mother tongue is Telugu, so I was always I know the fundamentals of the language, right? So I was able to easily learn the language, the other languages like Tamil. I was able to understand a bit of Malayalam also, a bit of Kannada also, right? So the fundamentals remains to be the same. It's the same. If you are knowing well MATLAB well, the Python is also very easy to learn. It's only that you have to understand some few features, right? So I've told you, right? So this pass by value, pass by reference approach. The Python has this pass by reference approach, right? So if I pass any variable to a function, and then if I tamper it, what happens is the variable outside this function will get affected. Okay, so but MATLAB is not like that. Okay, so it has its pass by value approach there. Okay, so you have to understand these kind of minor differences, and then you'll be able to do it. Okay? If you know MATLAB, then Python is also equally good enough.
Okay, sir. Thank you. Thank you, sure.
So this is the best course, madam. In fact, if you want to do Python programming, so Introduction to Computer Science and Programming in EDX. So this is the best course which I have seen. Professor Eric Grimson, I guess if I remember correctly, the instructor's name.
It is in EDX, sir?
Yeah, EDX, yes. This Eric Grimson, he teaches the fundamental Python course. The advanced Python course is also there, but fundamental Python course in EDX is really good. Okay. And you'll be able to do it very well, very easily. I think if you start from now, in 2 months of time, you will be able to master Python.
Okay, sir.
Yeah.
Sir, there is a question from Sunil Kumar.
Yes, sir.
Is the intensity value is fixed to 60 for all colors in programming?
No, this is for this particular case. Here the watermark is above 60 value. Okay, so I'm trying to capture all the pixel regions which has less than 60. Okay, that means only this what do you say, the tabular borders will come. Okay, suppose say if
Sir, if we change the value to if we change the value 60 to some other values, what will be happen?
So you try to analyze and tell me, madam, tomorrow. I will be waiting for your answer.
Okay, sir.
Okay, yeah. So I'll show you some images, right? So I was using few, right? So here the value will be something else. Okay, it won't be 60, it won't be 40,
Yeah.
or here the value
So
will be
how will
something.
you find that value? That is my doubt.
Yes, yes. Automatically you have to find out a value and then do it. By histogram you can do it, but I don't want to tell that right away. Okay.
Okay, sir.
Uh,
Okay, sir.
Yeah, because for every image, hard coding will be very, very difficult. So I generally, what do you say? You have to automatically build a way in order to do this. Okay, for which I want you to explore a bit, and then I have an approach. So I'll see if I can share it with you tomorrow.
Okay, sir.
But I want you to think about this and tell me in the first 10 minutes, 5-10 minutes we'll spend on this. And then you tell me a specific logic, how you want to automate this, or if you have a specific logic, you should tell me on how to do it.
Okay, sure, sir. I will try to find.
Sure, sure, sure.
Karthik sir,
Yes, sir.
there is a question from Mr. Jaychandrayan.
Yes.
Using this Colab, can we go for any other language?
I don't think so. I'm not sure. I think only Python is supported here. I'm not aware of it. Frankly speaking, I'm not aware of it, but I think only Python is supported here, as far as I know.
There is a question from M. Ramdas. Kindly specify the tutorial or document to understand about Colab for beginners, sir.
Colab for beginners, it's very simple to use, sir. So it doesn't take, it's not a rocket science also. Okay. So what you need to do is, let me start from beginning and show you here itself. Okay. All that you have to do is, you have to type colab.research.google.com. Okay. And then you will get into that website. Right, and then it will ask you to choose which of the Python notebooks. If it's not there, then what I do is I'll ask for a new notebook. This is called as a Python notebook. Okay, it's asked for this, and then I do my Python programming like this here. Right, and then I execute this cell. Here actually it's connecting still, the resources are not allocated. Yeah, now it is connected, so it prints hello world. Right, so I'll see if I can help you to identify the NVIDIA drivers. I want to do this, but somehow this command is. Okay, I'll fix this tomorrow and will let you know. Because the drivers will come automatically. The runtime change runtime type. The runtime is not connected. So it offers the free GPU actually, and if I select my resources as GPU, it will allocate GPU to me. Okay, initializing and connected, right? So now I'll execute this command. Okay, if you see here, 16 GB GPU RAM has been allocated to me. Okay, if you want to buy the same GPU for your desktop outside, okay, it will cost you few thousands of rupees. Okay, so such kind of a resource is available for you at your doorstep. So make the best use of Colab. Sometimes what happens is, now that because of the lockdown, a lot of people are operating from home. So the Colab has some difficulty in connecting. A lot of people are using the Colab in order to use it. Okay, so here if you see, the drivers are automatically installed, or CUDA is automatically installed. So if you want to do it all by yourself for your own laptop or a desktop, Okay, it will take lots and lots of time. Believe me, I wasted lots and lots of time like this. So this is the Tesla P100 GPU. Okay, let's see the price as well. Tesla P100 P price. Oh my God! See, P100 is $133,000. Let me see. It's almost like 10 million rupees. Okay, so that much worth of resource is coming to you at free of cost. Okay, so all that you have to do is you have to have a Google account and log into colab.research.google.com, and then you can start executing your Python commands over here. This is one of the best environment if you are having a good internet connection. But the only limitation is you need to have a good internet connection. And after 8 hours, the session will drop off, and then sometimes the GPU resource won't be allocated to you for next 8 hours or 6 hours, something like that, and then it will again reallocate to you for 12 hours or something. Okay, so that's a very best resource that is there on net as such.
Yeah, Karthik sir, you said EDX free online, right?
Sorry?
EDX free online courses, right?
Yes.
Is that paidable or what, sir?
I have did it for free. I think if you want a certificate, I think they may ask you money, but I did it for free. I didn't want any certificate.
Okay. These videos and that online courses are all free, right?
Yes.
Sure, sir.
Samir, what do you do, by the way? You're very active. Just trying to understand.
Yes, sir. Myself, Samir, I was completed my master's from ANIL College, sir.
Okay, very good.
Bhaskar sir is my mentor.
Okay, very good.
Naidu sir also is my favorite, sir. Because I was working in Appar University, Chennai, sir.
Okay, good.
It's one of the startup company which we use ATM surveillance. ATM surveillance company, sir. We are maintaining around 1,500 clients.
Good, Samir. Let's connect offline. Let's connect offline. Maybe we should talk. Okay.
Sure, sir.
And then I'll Naidu Garu, can you just read out other questions quickly?
Yes, sir. There is a question from Ranjit Kumar.
Yes.
Sir, which software is good for SAR image processing, MATLAB or Python software?
Python doesn't specifically has any libraries related to SAR. Some of my colleagues who are working with SAR, they are using MATLAB only. However, you can still use Python if you don't need any specific libraries as such.
Next question is from Vinodina Senthil. Is it possible to do image processing CV without GPU?
Yes, absolutely possible. So here, if you see here, for this code, I have not used GPU at all. Okay. So I'll run this so that you will have an idea. Okay, I'm just importing and then I'm running this. Okay, there is some error. I'll figure out. Okay, there is some issue with it, but yes, you can absolutely run. The GPU is not needed for running the OpenCV or any kind of a Python programming code. GPU is an added advantage. If you have it, your speed will increase.
So maximum how many images we can process only using laptop, maybe i7 or i4?
How much is your RAM, madam?
Mine is i7. RAM, I'm not sure about it. 8 GB RAM.
I think it will be based on RAM and also your image size. What is your image size?
My image size I have not yet chosen, but I would like to process 100 images, maybe with the size of 227 by 200.
Okay, but you want to use all the images together. What is your application? If you don't mind, may I know about it?
Actually, I am the image. Actually, I have video. I wanted to summarize the video, so I am getting maybe approximately 100 to 120 images from that video with the size of 227 into 200. So,
Okay. Yeah, if your RAM size is more, I think you can definitely do it, madam.
Okay, sir. Okay. So still I did not yet started, so I'm just confirming with
Yeah,
you.
that's a very good problem. In fact, video summarization, we are also working on it.
Okay.
One of the colleagues is working on it. I'm not working on it, but yeah, that's a very good problem to choose.
Yes. Okay. Thank you, sir. Thank you.
Welcome.
Next question is, sir, can we use SAI lab software for OCR applications? This is from N. Radha.
Yes, sorry.
Can we use SAI lab software for OCR applications?
Scilab.
Yes, sir.
I'm not sure if OCR is supported in Scilab, but because pyTesseract library is a wrapper for Python language only. Okay, you cannot use pyTesseract with Scilab.
There is a question from S. Radhakrishnan, sir.
Yes.
Can you tell something about night vision images?
Night vision images. What is that you would like to know?
Mr. S. Radhakrishnan, are you there?
Yeah. Yes, sir. Sir, this is regarding sometimes suppose a vehicle is moving in a dark environment. I think the driver could not able to know what is the object which is coming in front of him because of the lights what he is having and the light in front of the other vehicle also having, which is coming in the opposite direction. At the time, suppose in his from his front camera, suppose if the device is fitted, it can able to collect the set of in the form of video, and the video will be completely dark. So we have to make a device that which have to assist the driver in such a way that it has to tell which object is present in front of him. So at the time that the image or video what you are going to take is completely in the dark environment.
Correct.
We have also done some work with respect to the night vision type of problem. But the problem is paramount in terms of multiple cases. Case number one, suppose if this is this environment is happening in a complete background is having so many number of street lights. That is problem number one. Problem number two, suppose if the dark environment which is going out of the city, at the time if there is no moon at all in the night, I think there is problem number two. And the problem number three is suppose if the full moon is available, a similar environment, we will be capturing a different set of videos. So can we do some common set of algorithms for all the cases? This is still many companies are doing.
Okay.
This is what I mean for even China. I mean, there are some Chinese researchers are also working on with respect to this night vision type of images.
Okay. Okay.
Suppose if it is a hazy environment, I think the problem will be more complex.
Okay.
This is what I mean night vision images. So what algorithm? There are multiple number of algorithms are available. I think it is purely basically it is called as we have to go for some sort of nonlinear based algorithms. It is completely coming under image enhancement maybe. But provided if that is a complex set of images, what sort of algorithms we can able to go for? I think you know Prical. You know Prical, right? There is a company called Prical. Prical, they have started working on this actually.
Okay.
I was doing some consultation for them earlier. I was with Ph.D. Tech earlier, so in the Ph.D. Tech, I think we did some consultancy with respect to Prical, and I think currently the huge amount of works are also going on. So we cannot able to figure out a common algorithm which will, because the cases are different. This is what I mean for night vision images and what sort of algorithms we can able to go for. But it is a research case purely.
Yeah, please go ahead, sir.
Yes, sir. Yes, sir. You can comment, sir. Okay.
Yeah. No, have you tried homomorphic kind of an approach?
Yes, sir. Definitely. Yeah. Because
No, have you?
Yeah, we tried, sir. Actually, because the cases are different. No, actually, as I said earlier, all the cases it is not working well. So because it is I into R, basically, we are converting that into multiplication into addition. That is what a homomorphic filtering is doing. But it is not the case. It is not working well for all the cases what I listed so far.
Okay.
The environments are different, right?
Okay.
One environment it is doing, it is good, giving good results, but it is not the case with respect to the others. Others, it is completely failing.
Okay. So you asked me some question yesterday also, right? If I remember correctly.
Yeah. This is with respect to the medical images.
Right.
Yeah. Ultrasound images, I think I asked you.
Ultrasound images, right?
Thank you very much for your good memory, I think.
Yeah, not a problem. That was a unique question, by the way. That was because the night vision, I don't have much experience there. I can get back to you tomorrow. Are you there? Will you be there tomorrow as well?
Yeah, definitely, sir. Definitely. He'll be there.
Okay, I'll get back to you with the night vision thing. Definitely. Okay. And for this, the medical imaging question that you have asked, so one of our colleague has.
I asked about a region of interest.
Right, region of interest. Correct. So one of my colleagues who has worked on this medical imaging, segmenting these images, the tools in a medical imaging context. Okay. So so she has used, they have developed some unique algorithm based on deep learning. So if you can drop an email, then I can send you that link of that paper. Definitely, you can try that. Okay.
Okay, sir.
Anyways, you have some good amount of data.
Definitely.
Data set. I can give you, and then that particular algorithm you can see and try if that is working well or not.
Okay. If possible, you can also do some joint research also, sir. I think. If it permits you also.
But the problem with joint research is TCS has an approved list of colleges and universities. Which they are going to tie up, right? So that is the problem.
Okay, sir. I will drop a mail, sir. So we'll explore the possibility.
Yeah. But night vision thing, I'll definitely tell you tomorrow. Just in case if I forget, feel free to remind me.
No issues. Thank you.
Yeah. Thank you, sir.
Sir, next question is from Rajesh Shetty D. Sir, I know Photon 4. Can I understand and learn advanced Python?
Yes.
Sir, I know Photon 4.
Yes.
1 second, sir. Pratibha madam, please mute your mic.
Yeah. Yes.
Question is from Rajesh S. D. Sir, I know Photon 4. Can I understand and learn advanced Python?
Yes, of course it's possible. Just go through that EDX course I have referred to. You will definitely learn it.
One more question from KS Rao. Sir, any video processing technique using Python, sir?
Yes, a lot of our ultimately what video is all about. It's a series of images only again, right? So whatever you can do with the images, you can do the same thing with videos as well. Okay, all that you have to do is there is a video reader inside OpenCV, and then you can use that video reader in order to read your video and then do the processing as such.
So last question, sir.
Yeah.
Can we read directly JPEG or PNG format images for extracting features for machine learning applications for MRI medical image?
Yes, of course, you can do it.
Participants, that's all from your doubts. Are there any queries still?
Yes, some of my Ramdas sir, some of my colleagues actually are working on MRI medical images. They do read within the by using Python in a collab environment. They do read the MRI medical images.
Thank you, Karthik sir.
Yeah, you're welcome.
Participants, we have two instructions for you. Tomorrow the class will begin at 5:15 p.m. Kindly make a note of this. Anyhow, we will send it in the Telegram group and by mail. This is for your kind information. And one more thing, upon request from several participants, it is decided to consider best of 2 quizzes out of 3 quizzes. I'm repeating, we are going to consider best of 2 quizzes out of 3 quizzes for certification. Anything else from the participants?
No, excuse me, sir. When will this question for quizzes be posted? It will be better for all the participants to look it over.
Sir, it will be shared in the Telegram group, sir, like yesterday.
Okay, because I missed out it and checked only in morning. That's the problem. It's closed now. That's the thing.
Sir, are you registered in the Telegram group of this?
Yes. I noticed only morning.
No problem, sir. You please try these remaining 2 quizzes. Okay.
Okay.
And get best score. You please take care that you should cross 50% in each quiz.
Sir, excuse me, sir.
Yes, please go ahead.
Yesterday I didn't record my attendance, but I attended the sessions. Can you?
Sir, are you there in the Telegram group or you have our mail ID, right, sir?
Yes, sir. Yes, sir.
Please write to us. Please write to us. You have our mail ID.
Okay.
Thank you, participants.
Okay,
that's all for today. Karthik sir, thank you.
Yeah. Thank you. It's my pleasure. Bye.
Participants, if you have any problem, please write to us.